Hello everyone. In the previous video we have seen the three types of machine learning, which are supervised, unsupervised, and reinforcement learning. Today we are going to look at the main components of supervised learning. In supervised learning we have a data set given with labels, so the objective is to create a mapping from the inputs to the outputs. As a result, the first main component of a supervised machine learning is target function, which represents the true relationship between the inputs x and the output y, or the model y equals f of x plus e. However, this model or the true relationship between the inputs x and the output y is usually unknown. The second main component is datasets, consisting of labels, and usually this dataset is split into two for two different purposes. The first set is called train set and the second is called test set. The train set is used to train the model that can approximate the target function, and the test set is used to evaluate the performance of the trained model for unseen data or for datasets that is not used for training. The third component of supervised machine learning is model space, which consists of the set of all possible candidate models for approximating the target function f. Let's say this model space is M, consisting of f out of 1 of x, f out of 2 of x, and so on. Theoretically, the model space M consists of infinite number of models. So, for example, for linear models, the model space could consist of the different linear combinations of covariates, and for neural network models, the model space could consist of different network architectures or different weights. And the fourth component of supervised machine learning is optimization algorithm. The goal of the optimization algorithm is to select a model f out of x from the model space M that can best approximate the target function f. And this model f out of x is selected from the model space M subject to minimizing a function called loss or error function. So this loss or error function is an objective function that the optimization algorithm aims to minimize. Specifically, the loss or error function represents how badly the model is capturing the underlying patterns in the training dataset. Therefore, any supervised learning consists of these five main components: target function, datasets, model space, optimization algorithm, loss or error function. Let's see these components in a graphical form. Therefore, originally we'll have a target function y, f of x plus e, and for finding a model that can approximate this target function, we need to have a dataset consisting of inputs and labels. And for two different purposes, there is a need of splitting the dataset into two components. One into a train component, that's a training set, and the other test component or a test set. So the train dataset is used to train the model of interest through the learning algorithm. So the learning algorithm may select a final model, let's say y hat equals f hat of x. So this y hat equals f hat of x is selected from the model space M. So the errors obtained using that of the training datasets are called in-sample error or training error, and the errors from the test datasets are called out of sample errors or test errors. So in machine learning, our objective is to minimize both the in-sample error and the out-of-sample or test errors.